In this lesson you will create your first video game. This is what I get. What's up guys? Vasilis from Coding Chair here, along with Hectoras, and this time you can see my mic, mostly because my shirt is grey and the mic is black. Today we will be having the 6th lesson of Introduction to Programming, which will be about arrays, functions and random numbers, and how you can get the time from inside C, but we'll get to that. Before we begin, I would like to ask you if you like this video, or if you like this series, or if you like us, like this video, subscribe to us, comment below what you would like to see, what you would not like to see, what you like, what you don't like about this channel. Also, you can follow us on this social media. This is our snap code, you can snap it and add us on Snapchat. And that's about it, let's get to it. So, in the previous lesson, we learned about how you can get input from the keyboard, how you can display output to the screen, how you can control the flow of your program with if, else, else if, while, what else, for, do while, switch. We did all those statements. In this lesson, as I said, we're gonna be talking about the arrays, how arrays work in C, functions, and random numbers. So, arrays. I want you to imagine a spreadsheet in your favorite spreadsheet program. May that be Google Spreadsheet, Microsoft Excel, from WPS spreadsheets, whatever. You got a table, right? You got a cell, a cell, a cell, a cell, a cell, a cell. Can you imagine one column of that? Well, one column of field is a one-dimensional array. Now, if you got a lot of columns, one next to the other, that's a two-dimensional array. If you got little cubes that stack up on each other and next to them, that's a three-dimensional array, and so on. We will be talking about one-dimensional arrays, so I just want you to know about one column of data. This is what an array is: a collection of fields where you can input variables. So it's like a lot of variables declared in one. The general rule about how to declare an array is this: int, x, brackets, and the number. So let's say 5. So the idea is variable type, variable name, brackets, and the size of the array. So this 5 means we have 1, 2, 3, 4, 5 cells. For some reason you want to have 5 grouped integers together, which we will be calling an array. These 5 integers could be the top scores of a game, for instance. And you want to start putting the data into it. One thing you should be careful about is that when you declare an array like this, in the beginning it will have trust data inside, it will have values that are not useful to you. So you have to clean this, you have to clean those trust data. So you have to initialize your array. There are two ways to initialize your array. The first way is this. It's probably a bit long, that's why I ducked it. You can also omit the size of the array, so you don't have to go like top scores 5 and then brackets and the values. You can also omit this 5 and the array will be as big as many variables you have. So if you did this, you'd have the same exact result as in doing this. The second way you can initialize an array is a bit trickier. To understand this, we will first have to talk about accessing the variables of the array. Let's say you have this array and you want to take this value, the first one. To do this, you would go like int first value from array equals the name of the array, which is top scores, brackets, and then the index of the element you want. So the first one is 0, the second is 1, the third is 2, and so on. Third is 2, fourth is 3, fifth is 4. This is something I want you to understand very well because it's very important. Array indexing starts from 0 and goes up to array size minus 1. That means if you got an array of size 5, that means it has 5 cells, then the indexes of this array are 0, 1, 2, 3 and 4. See? 0, 1, 2, 3 and 4. That's 5 elements. Now that you know that, you may be able to see where I'm going with. The other way of initializing an array is this. So you got the size of the array, which is 5 in this case. You got an int array, int x, whose size is size of array, which is 5. We create a counter for a loop we will be doing right below. And then we got for counter equals 0, while counter is less than size of array. So we want to do something size of array times. Counter plus plus. And then inside this for loop we say take number counter element, so 0, 1, 2 element of the array, and set its value to 0. I believe that's quite simple. You just iterate through the whole of the array, and then you say I want this value to be 0, this 0, this 0, this 0. So you clean all the trash data and your array is initialized to being, zeros. Let's do a cool example using arrays. I will move out of the way because this is gonna be a big one. So let's say you have an integer, number of students, which is how many students you have in your class. Then you have an array which is their grades. So we got int grades, how big should this array be? This should be as big as many students you have, so number of students. Then we start a counter and we say for counter equals 0, while counter less than number of students, counter plus plus, and we print to the screen, enter the grade for student %d. I've worded it a bit different, but it's the same. And we say that we want to enter counter plus 1 student's grade. Why is this? The idea is that when you display something to the user, you don't really want him to enter 0 students number. You want him to see 1, 2, 3, starting from 1 and ending on 10. So we will do counter plus 1, which will take 0 and make it a 1. It will not affect the counter's value because it's not an assignment, it's just a statement, it's just an addition which will be used by printf. Then we do a scanf and we say read an integer from the keyboard and store it to this element of the array. So this will run 10 times, the user will input 10 grades, and then below we say that we do the same iteration and we check if the grade of student with number counter is less than 5, printf what student counter did not pass the lesson. Else print student counter passed the lesson, the course. Yeah, the course. This is a sample output for 3 students. Simple. Some lessons ago, I think it was 2 lessons, we talked about how you can declare a function. We specifically talked about the main function. And to freshen up your memory a little bit, the idea is that when you want to declare a function, you do something like this. The return type, function name, argument, and the block of code. So, what are functions and why should you use them? Sometimes in programming, you have to execute a piece of code multiple times. I don't know why, but your code needs, for some reason, to check if two integer variables are equal, and if they are not, to get the difference between them. And this needs to be done, I don't know, quite some times and in quite some places in your code. You wouldn't want your main to include this piece of code as many times as you will call this functionality. This way you would like to write it in a separate piece of code, a separate space. Let's say, for example, we need to create the function I talked about. We could do this. So int diff, and it takes as arguments int a and int b. If a is greater than b, then return a minus b. This returns the difference. And else return b minus a, which will return the difference again, or 0. Because if a isn't greater, then either b is greater or they are equal. Here is a big piece of code that has two functions defined and the main function. So let's see. We have the diff function we created before. We also have a print result which takes the difference of two numbers and says if the numbers are equal or not, prints it on the screen per se. And then we got main, which says int a equals 5, int b equals 6, int c is the difference between a and b, and then print result c. So we call print result using c as an argument, where c is the difference between a and b, and then print result by calling directly diff function between a, and then we just return 0. This is the way you can use your own functions inside main, having them declared above main. For the moment, always define your functions above the main function. In future lessons, we will learn how you can declare them afterwards, but for the moment, we won't go there. If you want to research it on your own, you're good to go. In the rest of this lesson, we will be seeing how you can use random numbers in your own code, and in the end we will be creating a simple game of our own. So in this lesson you will create your first video game. In order to get a random number, you have to call a function. Who would have guessed? This function is rand. Rand is part of the stdlib.h library, so this is something that's included in this library, and that's why you need to include it in your code before using the rand function. And rand will return a pseudo-random number and store it in a variable if you assign it. So if you've got int random number equals rand, then the result of this rand function, which is, again I say, a pseudo-random number, is stored inside int. The reason I am saying pseudo-random and not pure random or true random as it's called is because a computer is a machine that can only execute statements and instructions. These statements and instructions are well defined, so you can't really diverge from what's already defined. For that reason, there's a problem with using rand, and we will see this problem now. So let's see a little example using rand. We got main, a counter, and we want to print 10 random numbers. What do we do? Int number equals rand modulo 10. Why do we do this? We do this because we want our numbers to be from 0 up until 9. And what is the result of modulo 10? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, to continue, we do a printf of the number we have calculated. Let's see the results of running this code 4 times. Do you see what I'm seeing? Probably not, because I'm seeing a white wall. But if there was the text here that you are seeing now, you would probably see that the output of run 1, 2, 3 and 4 is exactly the same. And not only is it the same, it's in the same order, same numbers, same everything. This creates an issue, and this is what I am getting at. Rand will always return the same set of numbers, because in reality it's just a set of instructions that begin with one number, and by executing instructions on that number, by doing arithmetic computations, we get a random number, a pseudo-random number. So it's not really useful on its own. But I said that everything begins with a single number, and then from that single number we start calculating new random numbers. the way we can create better pseudo-random numbers but still pseudo-random is by changing this first number. Changing this number is called changing the seed of the random function. So this activity, changing this number, is called seeding the random number generator. In order to seed the random number generator, you just go srand, the number you want to seed it with, and then you can start calling rand. But we just change it to a static number. So if we call the program again, then we will get the same numbers again and again. We want something that's constantly changing, something that when we start the program has already changed from the previous time we started the program. Is there such a thing? Ah, there is time! You see, in computers, in order to calculate time, we use a predefined point in time, which is called the epoch. And we calculate the time difference between the epoch and the current time. The epoch is the 1st January of 1970. So you may have seen it in the internet nowadays, because sometimes when there's an error in calculating time, you get 1st 1970. This is the epoch. Many programming languages are equipped with the tools to calculate the time difference between the epoch and the current time. C is such a programming language and has a function which calculates the time difference between the epoch and the current time in seconds. So it's common to use this value, how many seconds it have passed between the epoch and the current time, the runtime of your program, to seed the random number generator. It's not something that is safe, and if you're in an enterprise that does this kind of stuff, maybe you want to look into something else. But for small programs and for educational purposes, it's quite fine to use time as a seed for your random number generator. In order to use time, we have to use this library, time.h. After including this library, you gain access to the time function. Let's see an example. So, we include sdio, we include sdlib, we include time, and then we say srand inside main, srand, parentheses, time, null, you always write null here, and then you end the statement with a semicolon. You only need to call srand once at the beginning of your program, if you have random numbers in your program, that is. After seeding, the program is the same program we saw before, so we just print 10 random numbers. So let's run this program twice. Ah! Now the numbers are different and they properly change. And I've added as a bonus to show how many seconds have passed since January 1st, 1970, and you can see that this value has changed. So, time to create our own minigame. We will be creating a minigame around guessing. So the idea is that we will create a number between 0 and 99, 0 and 99. And we will ask the user to guess what number we have selected between those two numbers. The user will then input a number, and if that number is less than our number, we'll say your number is too low. Or if it's higher, we'll say your number is too high. If the player finds the number correctly, then we'll say congratulations, you found the number! This is what I get. So now let's see the code of the minigame. We include the libraries, we start main, and then we got srand to seed. We got our random number, what's up here? Which we calculate by calling rand and then doing modulo 100, which will bind our number between 0 and 99. We initialize a variable input, which will be the input of the user, which is we will initialize to -1, because by initializing to -1 we are sure that it will never be between the bound of 0 and 99. Let's see. Then we'll say while input is different than our number we have guessed, printf, enter your number. Then we read this input, and if the input is equal to the random number, if input is equal to random number, wait, Hector needs to get down. If input is equal to the random number we have chosen, then we break from this while and we print congratulations, you found the number. Otherwise, we just have an else statement. If input is greater, printf the number is too high. If input is lower or just else, printf the number you entered is too low. And here is the output. This is the first game you've seen the complete source code of, probably. So, yeah, this was just a simple video game, right? The possibilities are endless. You know how to seed your random number generator, you know how to create random numbers, you know control flow. What's stopping you from creating your own little video game? This is where I'm getting at. We want you to create some small video game using the information and knowledge you already have from introduction to programming. I want you to think about it, what you want to do. I want you to write the source code. I want you to compile it, see that it runs, play around, give it to your friends, create something nice. I don't know what it is. You may as well create an RPG just by having the interface that text-based RPGs had in the 80s, like print something and then have the user select from a predetermined set of words. You can do everything. Sky is the limit. But I want you to create it and send the source code to us. I will check it. And in a future episode of Quickiversity, we will showcase the games you have created. I believe that probably 2 weeks is good enough, and you have plenty of time to create your own stuff. So in 2 weeks, the contest, not exactly contest, but submissions close, and we will showcase the best games that have been submitted, if any are submitted. In order to submit your stuff, you can use this email, submissions@codingjar.org. To recap, we've talked in this lesson about the following. What is an array? How to assign values to an array? How to define and use your own functions? Using and seeding random numbers? And we've talked about our first submission contest, your first video game. That's it for now. These are the social media I would like you to follow us on. If you like this video, subscribe to our channel, like the video. You can also comment below about what you would like to see in the future. This is our snap code. And if you have any questions that you need to express or you don't know how to contact us, now you do, because not only you have the Facebook page, the Twitter account, the YouTube comments, the Skype, Instagram, TikTok, Snapchat, you also have questions@codingjar.org. In this email you can send us all your questions and I will answer your questions personally. It was me, Vasilis from Coding Jar, and I want to wish you happy coding, everyone, expecting eagerly your submissions for the video game challenge. See you on the next lesson. Bye!